Hello, this is Jennifer Martinez, and in this video I'm going to show you how to prove the product rule. What is the product rule and what is it used for? Well, it's used to find the derivative of two functions that are products of each other. And what is it? Well, if you take u equals f of x and v is another function, g of x, and they're both differentiable, then to find the derivative of the product, that's what the left side means, it's the derivative of f times g plus the other way around, f times the derivative of g. A common mistake is the derivative of two functions, the product of functions, is just the derivative of the first times the derivative of the second. And you can see it is just not that. And we're going to prove that in a minute. But before we do, let's go over our alternate way of writing the product rule using our alternate notation. If you have the derivative with respect to x of u times v, right, where u was f and v was g, it's going to be the derivative of u times v plus, again, the other way around, u times the derivative of v. In other words, the derivative of a product is the derivative of the first times the second plus the first times the derivative of the second. So let's go ahead and prove it. So here it is. The derivative of u times v, which I am going to call u f of x and v g of x. I'm just going to use the limit definition. I'm going to plug in a f of x plus h and a g of x plus h, because that is my function there, minus the normal function, all over h. And I'm going to do something kind of tricky. I'm going to add and subtract the same term inside of this fraction. So let's do it in red so you see it. So the term I'm going to add, or subtract actually, I'll subtract first, because I want f of x plus h minus f of x here. And then I'm going to add it so I do not change the value at all. And I still have that f of x minus g of x. This is a trick commonly used in mathematics, where if we add and subtract, we haven't changed the line above at all. So now I'm going to factor out a g of x plus h, which was my goal there, to get just of the first two terms only, f of x plus h minus f of x. And then I'll put this over h here so I don't have to deal with it here. And then on this one, I'm going to notice that f of x is common. And I still have a g of x plus h minus g of x all over the whole thing over h. I just separated the two fractions. We know that the limit of the sums is the sum of the limits. So I can just take the limit as h goes 0 of the first plus the limit as h goes to 0 in the second. Same thing with multiplication, unlike derivatives, that is true with limits. So we can take the limit of each one here. So this first term here will be the limit of the first function times the limit of the second. That just looks like the derivative. If I do the same thing here, I don't even have to, this doesn't even have an h in it, so I don't even have to write the limit for that one. And then we have this term, and we have it, because we know that this is differentiable and continuous, so therefore this is g of x. It's differentiable, it is continuous. This right here looks like f prime of x. That is the definition of the derivative. And this is just f of x, and this would be g prime of x. And you say I made it smaller so we can see the formula. You can see the only difference is, I put that first, but there you have it. F of x, g prime of x. The derivative of f times g plus f times the derivative of g. Or if you'd rather the u notation, it could be the f is the u prime v plus u v prime. Or you can use this notation as well. And that does it. Hope that helps.